Hello, guys. Good afternoon. Okay, so today we'll be discussing about channel planning for Wi-Fi in general. So just it doesn't just cover the cloud, but this will cover the end sky solution as well. Today I'm joined by Michael and Nancy. So if you guys have any questions, you can type it on chat, or you can use the QA function as well, so that we can assist you. So let me proceed. As usual, if people come in late and you miss some of the first parts, then you can just over to our YouTube channel and check on the previous archives of this of our webinars. So the webinar today would be uploaded on YouTube by tomorrow. Okay, so today I'll be covering Wi-Fi channels in general, and what's the importance of Wi-Fi channels. These is a usual option on your access points, even routers at home. So why do we need to change the channel? What's the purpose, and what's the function for? And then some tips on pre-deployment, how we can plan out what channels to use when deploying, what tools you can use for deployment, as well as post-deployment verification. Okay, I just want to pull. I can see that most of you guys set the what do you call this channel on your AP to auto, or just leave it at default. Now, I'm gonna tell you why we needed to set it to a fixed channel and what benefits it will give you later on. So, Wi-Fi channels. Oh, first, what is a Wi-Fi channel? Now, as we all know, the access point, let's say EnGenius access points that we're using, most of the APs have two radios. So we have the 5 gigahertz radio and the 2.4 gigahertz radio. Now, these radios are running on different spectrums. So let's say the 2.4 gigahertz radio runs on 2,400 megahertz. Now, each of those frequency are divided into smaller clusters or smaller chunks. Now, those smaller chunks are what we call the channels. So that's the medium that we use to connect the access point. Now, if we look at the 2.4 gigahertz spectrum, it actually spans from 2,400 megahertz up to 2,484. Now, and then each of those certain frequencies has a how would I say? Each of those frequencies has a certain channel tag to it. For example, channel 1 is actually 2,412 megahertz, and then channel 2 is 2,417, and so on and so forth. Now, if you notice, the value difference between this frequency is 5 megahertz. Now, this is important to separate these channels to avoid interference, and then later on I'll go on. I'll talk about what interference is. Now, if we're using Wi-Fi and then we set a specific channel, let's say we set it to channel 6. Actually, it doesn't just cover 2437. Now, each channel on the wireless frequency has a certain range. For 2.4 gigahertz, by default, it's set to 20 megahertz wide. Now, the frequency that it covers is not just 2437, but actually spans from 2427 to 2447. Now, this will be important later on. So, for example, I have 3 access points running in 20 megahertz channel bandwidth or channel width. If I deploy 3 access points on channels 1, 6, and 11, I still don't have a problem. But if I deploy a 4th access point in the nearby location, that's where I start to have the issue. Let's say I deploy another AP on channel 3. As you can see, there's now an overlap of frequencies being used by the access points. So channel 3 is overlapping with channel 1 and channel 6 spectrum. Now, the overlap portion on your spectrum is what we call the interference. Because the frequencies are talking over each other, it causes this noise or interference. Now, the problem would start if you have more and more access points that you deploy. Maybe if you're deploying on a commercial area, then you would experience a bit of slowdown, a bit of intermittent connection as your APs overlap each other in terms of the frequency that you're utilizing. And if you set the power of your access point to a high transmit power or high what do you call this to the highest level, then you would have more and more interference because of the surrounding area. Now, the 2.4 gigahertz cannot only use 20 megahertz, but you can also actually set it to a 40 megahertz channel bandwidth. Now, there are pros and cons for this. If you set it to 40 megahertz, you would have more bandwidth. That means you would have more throughput. Let's say you're using a 300 Mbps access point. For 2.4, if you set it to 20 megahertz, you'd only get about 150 Mbps. But if you maximize it to 40 megahertz, then you can get the full 300 Mbps speed in terms of the throughput. Problem lies is if you look at the spectrum, the actual channel coverage becomes double as well. So let's say I set my access point to channel 1, but I set the channel bandwidth or channel width to 40 megahertz. You can see that it now covers two channel spectrums, channel 1 and channel 5, and it combines it to give you more bandwidth. And if I look at my spectrum, this means that in order to have a clean environment, I can only deploy a maximum of 2 APs in an area. This is the reason why we don't recommend setting the access point to 40 megahertz unless really necessary, and then maybe if you only have one AP on the location. Now, if you're using 2.4 again, and you set it to 20 megahertz channel width, you can have about 4 APs that are non-overlapping. So those channels are 1, 5, 9, and 13 to maximize it. But be careful when setting up an AP using channel 13 because not all devices are compatible with this channel, especially if the device is bought from the US. If it's a US bought, let's say, mobile phone or laptop, depending on the manufacturer, it can either be hardware and software locked. That means if you take it out of US, it still wouldn't be able to see the channel 13. But new devices right now, they work on a location-based system. For example, I take my iPhone, I bought it from the US, and I move over to Asia, and then I connect to an access point running channel 13. I will be able to connect without any issue. Some other brands, however, let's say, for example, DJI, so they have drones running on Wi-Fi frequencies. If you buy an FCC drone, meaning bought from the US, it's hardware locked to only work with 11 channels. So basically, you cannot connect to channel 13. So in general, if the device is in US, because they follow FCC standards, you can only play around with 11 channels on the 2.4 gigahertz spectrum. If if a device is bought from Japan, you can actually use 1 to 14. For the rest of the world, Europe, Asia Pacific, we can use channels of 1 to 13. Now, 5 gigahertz is a totally different story because 5 gigahertz have a lot of channels and they're spaced far apart from each other, 20 megahertz apart. So you would have less issues on 5 gigahertz in terms of interference than you would have with 2.4. So this is the same reason why we promote that you set up band steering as well as have your clients prioritize to connect to the 5 gigahertz channel because 5 gigahertz have higher frequency. That means that you have more throughput. You can fully maximize your new device, especially Wi-Fi 6 and Wi-Fi 5, as well as you would have less issues in terms of interference. Now, what are the effects of interference in wireless networks? So, interference can lead to slow connection, intermittent connection, and data loss in some occasions. So imagine, let's say in a small room, I have 5 access points. So let's say I set all of these 5 access points to channel 1. Now, all these APs will be broadcasting on the same frequency, which might confuse the client side. So imagine if you're the client, and then there are like 10 speakers in front of you or 5 speakers in front of you all talking at the same time. You wouldn't be able to understand what each of them are saying because they're all talking at the same pitch, at the same tone. Now, it would be the same with the access point. For the data to reach the client from the AP side, if all of them are talking on the same frequency, there would be a delay or slowness as the packet travels through the air to reach the client device. Now, interference is one of the major issues why you have issues on Wi-Fi. If you have a problem with the Wi-Fi, usually it's because of the channeling. Now, this can be solved properly if we did proper planning at the start. That means before we deploy the devices. Now, let's talk about the pre-deployment phase. So I mentioned that we can solve interference before you deploy the products because that's where channel planning comes in. So let's say you already know how many APs you're going to deploy at a certain location. Let's say it's a function room. So maybe the function room can fit 4 access points. So you have to properly plan what channel I need to set this access points to. Do I set it to channel 1, 5, 9? So that all depends. There's no fixed value. So long as no same channel would overlap each other, because then you would start to have your interference issues. So if it's a bigger area, let's say you would need to deploy like 6 APs, so the same concept applies. You would still need to deploy each AP with different channels that are not overlapping on each other, as an example on this diagram. So here, I made it sure that no two channels would be overlapping on itself. Now, later on, I'll discuss how you can test this on the site. But there are a lot of tools in the market. Even using our easy Wi-Fi planner from Reporter Portal, you can use this to do your channel planning. Now, this is an overview, basically a bird's eye view from the top. Now, what if it's a horizontal deployment? Let's say this is a building with multiple stories. Let's say this is a 5-story building. So when we deploy Wi-Fi for a 5-story building, we not just have to worry about the horizontal layout. Let's say here on the top floor, I have my APs on different channels, 1, 5, 9, and 13. So that's pretty fine. But I have to look on the vertical side as well, especially if you're deploying ceiling mount access points. Ceiling mount access points usually can penetrate to the lower floors, maybe 1 to 2 floors, depending on how thick the flooring is. And depends on the structure of the building as well. But always try to check if the bottom floor and the top floor has interference. So same concept applies on the previous diagrams that I've shown just now. So you have to make sure that your channels don't overlap each other. Okay, so what are the tools that we can use to check whether we have overlap so we can properly plan our deployment? So there are 2 key things that you need to use. First is a heat mapping software, and second is a Wi-Fi analyzer. So a heat mapping software is basically the Easy Wi-Fi Planner, if you guys are familiar with it. So the Easy Wi-Fi Planner, you can lay out a floor plan on the map. And then from there, you can lay out your obstacles, and then you can plot the estimate location of your access points. So the heat mapping software does a couple of things. First is it determines how big the coverage of your APs are to know how many APs are going to deploy in a certain area. At the same time, you can use this as well to plot out what channels do I need to set those APs to. So maybe some of you would think maybe I can just set the access point to auto and let the system try to figure it out on its own. Yeah, you can actually do that, but we'd still recommend to set the AP's channel to a fixed channel. One of my experience when I went out to a client location before with one of the SIs or MSPs, I would say in Malaysia, is that they really plan out the channeling. So I saw them using this software wherein they have the diagram of the whole hotel per floor, and each of the access point they really take down what channel is this access point set to, what's the transmit power. So if they have issues later on in terms of interference, they can just quickly check on their diagram and adjust from there on the system. Now, yeah, like I mentioned, the heat mapping software would help you in terms of determining the coverage of your access points, but as well as designing what channels you can lay out on your APs. Second tool that you can use is a Wi-Fi analyzer. Now, there are a lot of third-party tools in the market that you can use. There are a lot of free software as well. So you can have this on the PC, on Mac, on Android as well. For iOS, I think all of the Wi-Fi analyzers are paid. But basically, if you have a PC, you can just download Wi-Fi analyzer from the Microsoft Store, and you're good to go. So let me show you how that looks like. Let me just share my screen for a while. Okay, so this is one of the free Wi-Fi analyzers available on the Microsoft Store. Let me go to network. Okay, so using a Wi-Fi analyzer, depending on if you have a dual band device or not, you can scan the spectrums, 2.4 gigahertz or 5 gigahertz. Now, as you can see on the 2.4 gigahertz spectrum, it's very, very noisy in my vicinity. So I have channels of 1 to 13. Now I'm currently connected to 5 gig, so this doesn't affect me much. But I can see that this SSID right here has the strongest signal. So if I connect, for example, to this SSID, I may not have that much issue in terms of the connection because of the rest of the routers nearby have a weaker RSSI or weaker signal. But if let's say I connect to this ASUS right here, EA2G, then I may have a very, very bad experience because there are a lot of channels that are overlapping or a lot of devices using this channel right now. So there are APs on channel 1, there's APs on channel 3, and so on and so forth. So I mentioned a while ago that on 5 gigahertz, it's a totally different story because if you look on 5 gig, you would see that there are less devices on 5 gig. One of the reasons is maybe my laptop cannot scan hard enough on the vicinity because usually 5 gig have a weaker signal. But the pros are the less coverage that you have in terms of Wi-Fi connectivity, the less it's subjected to interference as well on the area, on the neighboring area. So as you can see, this SSID where I'm connected to right now, it has a very, very strong signal, and the rest of the routers are very far from it. So I would have a better experience in terms of connectivity on this SSID. Now, this tool, you can use this to bring on the site when you do a site survey. Let's say you're about to deploy the access point or you're just on the planning part. So this can help you determine what type of noise are there in the environment. Is there too much access points on channel 1? Are there, do I have an even number AP across all my spectrum, and so on and so forth. So yeah, heat mapping software and Wi-Fi analyzer. These are the two very important tools that you can use in terms of Wi-Fi planning. Now, what about post deployment? Let's say you've already deployed the APs, you've already planned it out. So basically, it's the same thing. Site survey, you would have to use this to verify if all your channels are correct. Let's say you're deploying on a 3-story building. So you go to the ground floor, you can check whether is my power setting okay? Did I set my transfer power high? How many APs I can see on this spot? So from there, you can verify if you need to make adjustments or not. By the way, I forgot to mention, usually when we deploy APs, try not to set the power to maximum. Because again, the higher the power that you set on one of your APs, the more it can cover a wider area. Now, having when your AP covers a wider area, basically it can see more APs in the vicinity, which can lead to overlapping channels because of interference. So apart from just setting a fixed channel, you would also have to set a lower transmit power as well. Now, maybe some of you would ask, okay, well, what value should I set that transmit power? Should I set it to 20? Should I set it to 15? Now, that's very, very subjective. Again, it would depend on the area. It depends on the walls. It depends on which area you want to cover. It depends how many APs you have. And you can figure that out if you use a site survey tool like a wireless analyzer. So apart from that, we have built-in tools as well on our controllers, on the cloud software, as well as the Easy Master, which can check what channels or APs are set on or to right now. Say, for example, these two APs on my floor plan, I can see that both of them are totally not interfering with each other, even though they're very close. If I'm not mistaken, this is like 6 meters apart. So you can see that one of my APs is set to channel 11 on 2.4. On 5 gigahertz, it's on 161. While the other one is on channel 6 and 36. So even if I set both of them to high power, assuming that there's no other APs in the vicinity, they wouldn't interfere with each other. Do you guys have any questions so far in terms of channeling? Okay, so let me proceed with the UI on the cloud. I'll try to show you guys the Easy Master as well, so you can see where you can adjust the channel, especially if your APs are already in a group. Okay, so now I'm at one of the networks, EnGenius SG Office. If I go to configure and then SSID, configure and then radio settings, here I would have the overall setting for the devices. So overall setting is set to auto, but I can easily override those channels on the individual AP page. So going to the AP side, If you expand your access points or you go into the details, you can see what channel they're set to. So right now, one of the APs has been overridden. It's set to channel 6, while the other one is set to auto because there's not much APs there in the office. So having this settings, basically this is where you can do the overriding. If you have like multiple access points, let's say 5, 7, or more than that, this is where you can do the adjustments on where you can change those individual options, such as the transmit power and the channel as well. So the channel width option is also here. So again, channel width determines how how big the frequency is you're covering per channel, as well as how much bandwidth you can have. So for 2.4, we always recommend it to set it only to 20 megahertz unless you really have just one access point in the area. For 5 gig, you can set it to 40 or 80. Now, if you want to use Wi-Fi 5 or Wi-Fi 6 speeds, you're going to have to set it to 80 channel width. Let me see if I can access the Easy Master just a while. Okay, so I don't have any live APs right now, but basically this is where you can change the channel. So if your APs are in a group, if you go onto your wireless radio settings, you would see your channel options. So again, this is for the whole group itself. But if you want to do the changes on specific APs, then you would have to override on individual AP settings. But since I don't have an access point that's live right now here on this Easy Master, I cannot change it. But basically, let's say you have an AP, just click on the model name, go into radio settings, and then click on override for you to override the individual channels. Okay, so let me go through the questions. Okay, one question here is when the channel setting is set to auto, is it auto detect during power up or can it adapt to changes? It depends on which system you're using. Let's say, for example, you're using the Easy Master on NSky. What happens is by default, it will only scan the channel the moment you power up the access point. So the same thing applies on standalone mode. When you boot up the AP, it's going to go into its self-test. At the same time, it's going to do a spectrum scan. So it's going to scan the whole spectrum, 1 to 13 and 36 to 165. So after scanning, it tries to figure out which one has the least interference and then stick to that channel. So from then on, it wouldn't change the channel at all. Now, if you have background scanning enabled on the Easy Master, that can be enabled from this site. And then your channel is set to auto, then it's going to scan each channel every time, depending on the duration that you set it. On the EnGenius Cloud side, scanning happens periodically as well. So let's say now your AP is set to channel 11. After a while, it can go to channel 6, depending on how much interference you have. Okay, another question here is between two access points that are close to each other, how do you determine which channel is the best and what channel should you set it to? Okay, like I mentioned a while ago, let's say you're doing a deployment or a pre-deployment. To know what channel you're going to set to the AP, you're going to need to like do a good estimate depending on the location. So you can use a site survey tool to check what channels can you utilize. So I would stick to the channel that's least occupied and that's least utilized. Wait, let me open up my scanner again. Okay, so for example, in this location that I'm on right now, so what should I set my access point on 2.4? What channels should I set it to on the 2.4 side, knowing that there are a bunch of APs here in the vicinity? So right now, this SSID Noel Guest is actually set to static IP to channel 11. The reason behind this, if I set it to channel 1, there's a Singtel device that's very close. So that would cause interference on my location. So to know if the device is close to your location or not, it's through the RSSI value as well. So the higher it is here on the graph, that means it's closer to your location. So channel 5 is pretty much occupied as well. And there's this SSID running right here. So the best channel to select on this moment for Noel Guest would be channel 11. It's because that's the one that has the least amount of APs that are close to this location. So 5 gigahertz side, it's pretty easy to select which one I can use. So I can see right here that most of the access points in this area are below negative 80 dBm. So anything more than negative 80 has a very, very weak signal already. So this can translate to 1 bar or 2 bars on your connectivity from your client device. So having that said, if let's say this is the channel that I want to uh, I mean, this is a spectrum that I want to power on a new access point. I would set it to channel maybe 36 or 44 or 48 in this area because it has the least interference that is close to my location. Okay, so another question is kindly share the slide on the 5 gigahertz spectrum for DFS. Okay, just a while. Let me open that up. Okay, here you go. Yeah, so another question is in 5 gigahertz with auto channel scan, how does it select the proper channel according to situations? Okay, so the way that the scanning works is depending on which system you're using. Is let's say you set your access point to auto. When it scans the frequencies, it checks two things. First is how many APs are nearby, what channel are they running. The second thing is what's their RSSI level. For example, I have an AP right here, APA, and then it scans the area. I saw there's APB and I saw there's APC. Now APB is running, let's say channel 1, and then APC is running channel 11. Now channel 1 is very close to me, this access point, and channel APB is very far from me. So your AP would then determine, can I use channel 11 as well since that AP is far, or do I use channel 6 instead? Because there's no access point in the area running the same frequency. So that's how it selects it. So the same thing applies for 2.4 and 5 gig. But on the 5 gigahertz side, it's a bit different, especially for outdoor deployment. Because on 5 gig, you have the so called DFS channels or dynamic frequency selection channels. So those are channels 52, channels, 52 up to 144. So if you have an access point, let's say an outdoor AP, maybe for point to point or point to multi-point, and then you set it to channel, let's say channel 100, and then you didn't know that in the vicinity there's a weather equipment or a radar equipment nearby that suddenly broadcasts as well using channel 100. What your AP will do is it's going to be forced to jump over a different channel or go on standby, depending on the circumstances. That's because DFS is required to be applied on wireless radios, especially outdoors, because these are like regulated channels. That means these channels are actually being shared with radar equipment and weather equipment as well. And we have to prioritize the utilization of those equipments. So radar equipments and weather equipment will always be prioritized. That's why when deploying outdoors, we suggest to not use DFS channels. So that would be the green channels here on the diagram, 36 to 48 and 149 to 165. Another question is, how do we disable DFS channels in auto channel? When you set it to auto channel, okay, on the Easy Master right now, we're gonna have a new feature which we call channel selection. So I mean smart auto channel selection. That means, for example, I set it to auto. You can select which range will your access point select from. For example, you only select 36 to 48 and then 149 to 165, and then you set it to auto. So it's just going to choose amongst those. But especially for outdoor deployment, point to point or point to multi point, I would highly suggest to set it to a fixed channel and not auto. Okay, another question here is, can you explain more in the channel width? Okay, so let me go back a bit. Okay, so again, the channel width determines how big your channel occupies in terms of the frequency range. So the bigger it is in terms of the range, the more bandwidth you would have because it's occupying two channels at the same time. So this is synonymous to channel bonding. So let's say I have an access point, I send it to channel 120 megahertz. So these are the frequencies it occupies. It has a certain maximum bandwidth or speed as well that it can allocate. Now, if I switch this access point to 40 megahertz, it now would combine two channels at the same time. So that's channels 1 and 5. So combining two channels means um, you have more roads that you can send data to. That means you have a bigger what do you call this? Bigger road that you can send data to have more bandwidth to go through. This at the same time increases your bandwidth. So imagine uh, Ethernet cables. If I have one Ethernet cable, I would have X amount of speed. If I have another Ethernet cable, then I do aggregation. I can combine both those speeds. So the same thing happens when we use a higher channel width. Okay, so which option is better, auto or manual? For most of our recommendations, we always recommend to set a manual channel, especially if you're deploying a lot of access points. If you have, like, let's say 1, 2, 3 API deployments, maybe you can set it to auto. But the moment that you're going to deploy more, maybe 5, 10, 15, 20, or 50, it's always best to set it to manual. Because later on, end of the day, you would have less headaches as well. Let's say you deploy 50 access points on a hotel. You just set it to default, set the power to default, set the channel to default. The problem will go, you wouldn't see the problem right away. It would happen later on. So after deployment, let's say the hotel opens, and then they would start to have guests. Now the guests you definitely complain a lot. They would say that, hey, having poor Wi-Fi connection in this room. It's either disconnected always, or I'm connected, but it's extremely slow. Now, if channel planning is not done properly, you would definitely have that headache. But if you did it properly the first time before installation, then you would have less of those technical calls. Okay, another question here is, can we set the power to auto? Power can be set to auto, but same with channeling. As much as possible, I suggest to set it to a channel that's just enough to cover the area that you want to. Let's say, for example, I want to cover a small room, a small space. I wouldn't set the AP's power to maximum, because if I set it to the minimum amount, I can already cover that same space. So the downside there is, if I go out the room, I wouldn't be able to connect to the AP because the signal is weak. But if I increase the power, the signal coverage of that AP will go outside the room as well. But if I have another AP outside the room already, then both of them would overlap each other's frequencies if they're on the same channel. So power and coverage is directly proportional to each other. Okay, any advice on how to design channeling for a hotel if AP is installed in every room? So that's a good question. Let me pull up another slide just a while. Okay, so this slide right here is part of our ESS NSky, our EnGenius Solution Specialist certification for the NSky side, where we talk about channeling as well. By the way, if you guys are interested to join, you can sign up from the website. So the question was, what channeling can we advise in terms of in-room deployment? Now, APs deployed in-room would give you better results in terms of channel planning, because it's way easier to deploy APs inside a room. So a quick comparison here is, let me get my highlighter. Okay, so the 4 diagrams right here, the one on the left side are APs deployed on the hallway, while the ones on the right are APs deployed inside the room. So as you can see on the hallway here, there are like 1, 2, 3, 4, 5, 6, about 9 APs on the hallway. So you can see that the signal is very, very good on the hallway side. But as you go inside the room, maybe on the work table or the balcony, you get weaker and weaker signal. Now, if you look at the interference level, since the APs can see each other, they're very close to each other, the signal has nowhere to go. It'll just bounce back and forth the whole hallway. So you have tons of interference here. So what this means is the people inside the room would have a very, very slow connection. First is because the signal is weak inside the room. Second is there is too much interference outside. The data experiences a lot of latency and maybe packet loss as well as it goes or as it penetrates inside the room. Now compare that on the right diagram where you have APs deployed inside the room. So here the APs have good signal where you want it to be. At the same time, if you look at the interference level, since you have a lot of walls that are blocking AP to AP, basically there's less and less interference here because the signal overlap is less as well. So even if I set, let's say, all the APs here on this floor to channel 1, I would still have less interference because I'm utilizing the walls of the hotels to block off each other's signal. So I have less overlap if the AP is deployed inside a room. Now, the biggest downside if the AP is deployed inside a room is basically for some clients it would be the cost because they would need to shell out more cash to purchase additional APs deployed on the rooms. When I say APs deployed inside a room, it doesn't necessarily mean you need to have one access point in each room. Again, like in this diagram, one AP can still cover about 2 to 3 rooms. Okay, another question is normally we set channel 1, 6, and 11 for 2.4. What happens when you set it to 2, 7, and 12? Okay, let me go back to my other slide. Okay, let me show you this instead. So the question was, what happens if I set my spectrum to 2, 7, and 12? Would there be an issue? Not at all. As you can see right here, if I shift the channel, let's say I set it to 12, 7, oops, channel 7 and channel 2, you can see that the channels are still not overlapping on each other. The only downside would be is if you're deploying 4 access points, then the fourth AP would definitely overlap the rest. Now, if I set it to, like my example a while ago, 1, 5, 9, and 13, I have another free channel that I can set it to so I can have more APs to deploy. But again, deploying APs on channel 13, you need to be careful, especially if you have a lot of devices there that are purchased from the US, because those devices may or may not be able to connect your AP because they will not be able to connect to channel 13. A good concern right here is multiple APs with the same SSID but different channel. So how can Wi-Fi roam without disruption there if you have that kind of setup? So fast roaming is not affected by your channel. So a usual misconception is, okay, when I have fast roaming, that means that if I want to move from one AP to one AP without disconnection, all my AP need to be on the same frequency. But that's not the case. So for fast roaming, even if your APs are on different channels, so long as you're on the same SSID, I mean, you have the same SSID, same encryption, and those APs belong in the same group or belong to the same network with fast roaming enabled. Fast roaming would just work. So let's say I'm moving from this AP channel 1 and then I move to channel 5. There wouldn't be any disruption at all. So latency for our fast roaming is about 50 milliseconds. So if I'm using VoIP services, there wouldn't be any disconnect. Okay, another question is if we deploy APs on the hallway and then we set the channel to auto, in that case, what is the probability that interference is there? So you would definitely have interference if you set your APs to auto. The AP would eventually try to change or cope with it. But if you have done manual channeling at the start, then you would have less of those issues. At the same time, your AP would utilize less processing power in order to determine which channel to stick to from time to time. Unless you're using an access point that has a scanning radio. Let's say, for example, our ECW 620 and 630. So that AP or those APs have a dedicated scanning radio, which can work on auto channeling properly for you. Another question here. Although it's third party, how is FortiGate able to deploy a wireless network on a single channel without interference? I'm not really familiar with FortiGate. I'm sorry about that. I'm not able to answer that. But interference and channeling in general is the same amongst all the brands, whether it's Cisco or Aruba, Meraki, or Ubiquity. Interference is there no matter which brand you go to. Okay, another question here is fast roaming 802.11 R standard. Is it default enabled on new AP only? Actually, no. You can utilize our fast roaming or 802.11R. Actually, we also use 802.11K as well as 802.11V. So these standards are available on all our existing products. And you can enable the setting on the SSID menu. Yeah, again, if you want to know more in depth about our products, let's say NSky or the EnGenius Cloud as well, if you need to know in depth technical matters, you can sign up on our certifications. So we have we have a lot ongoing weekly right now. So just let the country managers know, or the salesperson know, or your distributors as well. You can also sign up on our website, engeniustech.com.sg, if you're interested on taking online certifications. Yeah. So again, question is: some hotels are required to have one access point each room. What is their recommendation? So deploying an AP inside the room would be very, 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 very easy for the installer, because you wouldn't have to worry about channeling that much. Now, if you deploy an access point inside the room, you have a lot of walls to cover your coverage. So an access point inside a room, maybe if it's a studio room, you can set the channel power to the lowest, but still have a good signal inside your room. Even if all the rooms have the same access point on the same channel, you wouldn't have any issue at all. If it's a suite, maybe one bedroom, two bedroom suite, maybe you need to jump up the power a bit. Let's say 15 dBm or 17 dBm, depending on, again, the site survey. Now, power is very subjective on the location. Depends on how thick the walls are. What environment is it in? Are there a lot of devices nearby, wireless devices? So a site survey would be the best to use on that situation. Okay, another question here: is EasyMaster a free tool? EasyMaster is actually our wireless controller. So this is utilized by the NSky system. On the other hand, we have the EnGenius Cloud, which is purely cloud as another management tool. Okay, who can I chat to regarding third-party integration with Captive Portal? Lineify. Okay, Mr. Richard, you can speak to the country manager from EnGenius, the one that's handling you guys, and then from there we can work on how the integration would be in terms of third-party Captive Portal integration. Okay, another question here is 802.11ax or Wi-Fi 6 in the works? Yeah, actually it's available right now for both NSky and the Easy Master. I mean, NSky and the cloud. So for the NSky series, we have the EWS 220. Oh, sorry, EWS 357. That's 2x2 Wi-Fi 6, and EWS 377 4x4 Wi-Fi 6. That is available right now. For the cloud version, the pure cloud version, EnGenius Cloud, we have the ECW 220 2x2 and ECW 230, which is 4x4. So Wi-Fi 6 is already available for EnGenius products. Soon, maybe around Q3, we'll be having outdoor Wi-Fi 6 products as well for hotspot functions. Why is there a difference between cloud managed APs and Easy Master managed APs? Other brands use the same AP but utilize different firmware. Okay, very good question here. Now, EnGenius have different platforms. Again, one is the EnGenius, what do you call this? EnGenius NSky solution, which utilizes the Easy Master and the EWS, EAP, ECB access points. While on the cloud, we have the EnGenius Cloud solution with a totally different hardware. We call this the ECW series. Now, this hardware are actually different from each other in terms of performance and capabilities. Now, NSky solution access points are very versatile in terms of having them on standalone mode, meaning you can manage them one by one, or having them managed by a controller. Now, the pure cloud system, you use a totally different algorithm in terms of talking to the cloud, communicating to the cloud. That's why we use a different system. Now, the ECW access points are purely cloud-based. So these APs cannot be managed on standalone mode. They can only be managed on the controller side. Now, different clients have different options to select too, depending on what type of system you want to deploy. Let's say if they're keen on using a controller on premise, then they would have to use the NSky solution. But if they want a pure cloud solution, depending on what functions they need, then we could suggest them to use the EnGenius Cloud. Now, think of it as totally different systems, as in separate functions and different purposes as well. I hope I answered your question. Okay, last question here. Do we need cloud switch when using EnGenius Cloud? No, you don't. So if you want to deploy EnGenius access point, and let's say you already have existing switches, you may go ahead and do so. So the controller and the APs, I mean, the APs and the switches are independent from each other. So our switches work as a fully managed layer 2 switch with static routing functions. At the same time, our access point works as a pure AP. So they're not really dependent of each other. But of course, there are some functions that you would miss out in case you would not use our switch. One of them is the topology view. So to utilize the topology view, this is where it maps out your network automatically. So you can find everything on the screen. You can find where the APs are plugged into and so on. So you can only have that function if you have an EnGenius Cloud switch. So I highly recommend to have at least one EnGenius Cloud switch on the system if you want to use the topology view. Okay, last question really. um, does EnGenius have a portable spectrum analyzer? We don't have a, let's say, a handheld spectrum analyzer like what Cyber has or Fluke Networks has, but actually you can use any of our standalone access points to work as a spectrum analyzer. So let's say you have an EWS AP, and then let's say you're using the EnGenius and Wi-Fi application. So you can connect to that access point and make it act as a Wi-Fi analyzer. So you just have to go into the app, access the AP, and then select scan. So from there, your access point will scan the environment to check either 2.4 or 5 gigahertz channels, which one are occupied, how many APs are there, how far they are in terms of RSSI value, etc. So yes, so that'll be all for today. So again, if your guys are interested in taking certifications, technical certifications or online courses, then please sign up on our website. So you can either sign up on ESS and Sky or ESS Cloud Solution. So again, thank you all today. Take care, guys.